Yes, so we have completed the theoretical part of determinant chapter. Now we are going to solve some questions that are asked in previous year papers of UPSC ND. So as we are all okay, so the first question reads, what is the value of the determinant? And the determinant is given to us. There are factorial elements in factorial form. So we know how to solve these. So first of all, we can take something common from the first row. No. Second row, yes, we can take common. That is 2 factorial. From the third row, we can take 3 factorial common. Because let me simplify how exactly what I'm saying, how we can take common. So basically, 3 factorial can be written as 3 into 2 factorial. Or let's say 4 factorial can be written as 4 into 3 factorial. Okay. So why 3 factorial? Because 4 factorial is 4 into 3 into 2 into 1. Now 3 into 2 into 1 is 3 factorial. So that's how we are taking common. Okay. If it's that clear, let's move on to the next step. Taking 2 factorial common from the second row, third factorial common from the third row. So now the first row remains the same. 1 factorial, 2 factorial, 3 factorial. 2 factorial gone, 1 remaining, 3 factorial upon 2 factorial, 3 is remaining. 4 into 3 into 2 factorial. 2 factorial is gone. So 4 into 3 becomes 12. 3 factorial is gone, 1. 4 factorial is 4 into 3 factorial. 3 factorial is gone, 4 is left. 5 into 4 is left, that is 20. Okay. So 2 factorial is what? 2. 3 factorial is what? 3 into 2. Sorry. 2 factorial is what? 2 into 1. 3 factorial is what? 3 into 2 into 1. That is 6. Great. 2 into 6, 12. 1, 1, 1. 2 factorial is 2. 3 factorial is 6. 3, 4, 12, 20. Now let's solve this simple determinant. And we can expand using the first column. Okay. Expanding the determinant using the first column. Now, when we multiply 1 with this, the determinant of this particular factor of 1, particular cofactor of 1. So 3 into 2. So basically, into 1 into 3 into 20, 60. Minus 12 into 4, 48. Minus of 1 into 2 into 20, that is 40. Minus 4 into 6, 4 into 6, 24. Plus 1, this element this time. 1 into excluding the respective row and the column. 2 into 12, 24 minus 6 into 3, 80. So that is the expansion of determinant. Is there any doubt in the expansion of determinant?
No, sir.
Okay. So 12, 60 minus 48, that becomes 12. 40 minus 24, 16. 16 into minus 1, minus 16. 24 minus 18, 6. Okay, 12, 6 becomes 18 minus 6 becomes 2. So 12 into 2. That should be 24. Option C should be the correct answer. Yes, it is. Any doubts, anyone?
No, sir.
Okay. So why exactly we have taken common from second and third row? The reason is to simplify the further calculation of determinant. Otherwise, if we were to expand it directly using expanding the factorials here. So 1, 2, 6, 2 factorial is 2, 3 factorial is 6, 24. Okay, 6, 24 and 24 into 5, that is 120. So now expanding this determinant would be harder for us because of the greater numbers. So we would have to multiply larger numbers and subtract then the more larger numbers. That's why taking common helped us. Okay. Is the question clear?
Yes, sir.
Now the next question. What are the values of x that satisfy the equation? Okay, now the sum of two determinants are given as equals to 0. So now let's expand the determinant one by one. So in the determinant, we can see if we have to make some certain, okay, so let's, without doing any operation, we can just take the first row because it has a 0 in first row here also, to expanding the determinant. Expanding the first determinant, x into x, now excluding the respective column and row, 2 into 1 minus 1 into 1. Okay, so 2 into 1 into 1 into 1, 2 into minus 1 minus 0, anything, it doesn't matter, 2. Now excluding the column and the row, 2x into 1, 2x minus 2 into 1, that is 2, plus, now expanding this determinant using the first row, the first element, 3x, its cofactor, excluding the row and the column, 2 into 1, 2 into 1 into minus 1 into 1. Minus of 0, anything doesn't matter. When it's get multiplied with 0, it becomes 0. Plus 2. Now cofactor of 2, excluding the row and the column, x square into 1, that is x square, minus 2 into 0, that is 0. Now it's given as equals to 0. Now let's expand. 2 minus 1 becomes 1, x. This becomes 0. 2 into 2x, 4x minus 4, 4x minus 4, plus 6x, minus 3x, 0, plus 2x square. Now there will be two values for x. This is a quadratic equation, that's why. Okay, let's now expand it to x square plus 3 plus 6x plus 6x minus 3x. This becomes plus 3x plus 4x plus 7x plus 8x minus 4 equals to 0. Now let's divide both of the sides of the equation by 2. This becomes x square plus 4x minus 2 is equals to 0 by 2 is 0. Okay, let's now find out the root of this equation. So using the Sridharacharya formula, which is x is equals to minus of b. B is 4 here, plus minus b square 16 minus 4 into a is 1, c is minus of 2 divided by 2a. Minus 4 plus minus divided by 2. Now 16 minus this plus the minus gets multiplied, makes it a plus. 4 into 2, 8. 16 minus 8 is square root of 8. Square root of 8 is 4 into 2. Now square root of 4 is 2, and square root of 2 is root 2 only. So the square root of 8 can be expanded as 2 root 2. So this becomes 2 root 2. Now dividing it by 2, 4 by 2 becomes 2. Now 2 gets cancelled by 2, root 2 is remaining. Is it matching with any of the option? No, it's not. We have done some mistake, I guess. X, 4x minus 4, plus 6x plus 6x minus 3x. I guess we have interpreted this miswritten 6 and we have misinterpreted it with 1. Let's calculate the sum here. Plus 2x square, okay. Plus x plus 4x, 5x plus 6x, 11x minus 3x. 11x minus 3x should be plus of 8x. Okay, that is right. Minus of 4. Okay. Now dividing the equation by 2, x square plus 4x minus 2. Okay. X is equals to minus of b plus minus square root of b minus 4ac, 4 into 2, 4AC. Okay, 4A is 1, C is -2, 4AC. Okay, great. 16 plus 8. Okay, 16 plus 8 should be the case. So it should be 24. That is where we have done the mistake. Square root of 24. 24 can be written as 4 into 6. Right? 2 into... Wait. Uh, Instead of writing it as 4 into 6, can we do something else? 4 into 6 ही लिखना पड़ेगा. We have to go with 4 into 6 only because there is no other perfect square which is a factor of 24. So 4 square root is 2, 2 root 6. So this becomes 2 root 6 now. 2 cancels -4, this becomes -2. 2 cancels 2, now it will become -2 plus minus root 6. And D should be the correct answer. Yes, it is the correct answer. Option is written. There's a misprint in writing the option here because it's not root 3, it's root 6. So D should be the correct option. And the solution here given in the book is correct. So D should be the correct answer. Any doubt? It was a simple question. First, we did a mistake in simple writing the sign. That's why we had to waste that much of time. So simply, we have to find out the equation, the value of x, because that's the only variable in this equation. We'll expand the determinants one by one. After solving the sum, we'll have a quadratic equation. So using Sridharacharya formula, which says that there is a quadratic equation ax square plus bx plus c is equals to 0. Now the x, the root, the value of x for which the quadratic equation is satisfied is there is a quadratic equation ax square plus bx plus c is equals to 0. Now the value of x for which this equation is satisfied is x is equals to minus b plus minus. Let me write it on the next page. Okay, my laptop needs some rest. Okay. So Sridharacharya formula says that if there is any quadratic equation in this format, ax square plus bx plus c, so the value of x for which the equation will be satisfied is known as the root, and that will be given by minus of b square root of uh, minus of b plus minus square root of d divided by 2a. What is d here? D is discriminant here, which is b square minus 4ac. So hence x can be written as minus b plus minus square root of b square minus 4 uh, b square minus 4ac divided by 2a. Any doubts?
No, sir.
Okay. Moving on to the next question. If it is given like x is equals to a plus x plus a plus b plus c is equals to 0. Okay, there are four variables in this linear equation. Now we have to find out the value of this particular determinant having four variables, the same as the condition. So, and there are also a, b, c variables in the options. Okay, so how about if we put any value for these variables satisfying the given condition, then the particular value that we'll be getting after the determinant will match with one of our option. As we have put in some value for A, B, and C, so we'll have to modify our options as well. So let's now think for some easy values for A, B, C, and X. I believe if we put A, B, C as 0, then there will be one problem that A option, B option, and C option will all become the same. So we will not be able to distinguish in between them, among them. So it's better to go with some different values. So taking A as 1, B as minus of 1, C as 0 can help us. And taking um, X as, we have to take certain value of X should be no. Let's ignore X. Let's take X is equals to 0 also. Okay. So now our options becomes, this remains the same. B option will become A plus B plus C. That is one that becomes 0. Okay. Now this becomes 1 plus 1 plus 0. This becomes 2. This option becomes. So now our two options are becoming the same. So there will be a confusion. There will be a confusion if our value of the determinant comes out as 0, whether to mark A option, B option. So we cannot also go, we can also not go with the same. So let's take A as 2, 2 minus 1, that becomes plus 1. Let's take X as minus of 1. Now that will be better. And now let's now check for the options. Now what the options are becoming. So simply we are putting value for X, A, and B, and C. And we are getting the value satisfied with the condition that is given to us. This is the condition that is given to us. Okay. Now the A option remains the same. B option becomes A plus B plus C. So 2 minus 1 plus 0 whole square. That is 1 only. C option A square plus B square plus C. So A square, 2 square, 4. Minus 1 square, 1 only. 0 square, 0 only. This becomes 5. D becomes A plus B plus C. Okay, A plus B plus C is 1. 1 minus 2, that is minus 1. Now we have all the options are different. A option is 0. B option is 1. 5 minus 1 as per the value that we have assumed for. X value minus 1, 2 is, A is value 2, B is value minus 1, C is value 0. And also the condition is getting satisfied. So we are good to go. So the determinant will become x plus A minus 1 plus 2, 1. Minus 1 plus B, minus of 2, minus 1 plus C, minus of 1. Now B, minus 1, C, 0, C, 0. A is what? 2, and B is what? Minus of 1. So now we have to solve for this particular determinant. Now in the third column, we can see that the third column is having the maximum number of zeros. So that's why we are going to expand through this particular column. Okay, so 0 into anything, doesn't matter. Minus 1 into its cofactor. Now this position is third row and third column. So the sum of 3 and 3 is even. So the sign will remain the same. 1 into minus 2, minus 2, minus to minus 1 into 2. Now minus 1 into 2 is minus of 2. Minus of 2 when gets multiplied with this becomes positive. This gets cancelled and the determinant becomes 0. Now B option is not matching, C option is not matching, D option is not matching, only A option is matching. So that's why A is the correct answer. That is what is given also. Otherwise also without value putting, you could have just added C1, C2, C3. Operation you have to go with the operation C1, C2, C1. You have to add basically all the columns and you are operating on first column. Now you will take the common, take X plus A plus B plus C common, and then it is given as equal. So after taking it common, you will write the determinant will become like this: 1, 1, 1, B X plus B, B C C C X plus C. Now you know if this is 0, if 0 is getting multiplied with anything, then the whole value will also be 0. So if this is 0, whole value will also be 0. That's why you could have marked option A. Using this method also and using value putting method also. Is that clear? Please read the solution again. Red. Do I repeat the solution, Yarini?
No, sir. Clear, sir.
Let PQR be three distinct positive real numbers if the determinant D is the determinant like this PQR, QR, PV, RPQ, then which one of the following is correct? So if PQR are be three distinct positive real numbers, so let's just consider them. Okay, we can, because the only condition of for PQR variables is that they should be distinct and positive real numbers. Distinct means they should be different numbers, and positive means they have to be positive real numbers. Okay, let's consider them. So if PQ is 2, R is 3, so they are distinct. Okay, 1, 2, 3, they are distinct. They are positive, all positives, and real numbers. Great. So now D will look like 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay. Now let's solve for this determinant. That is very easy. 1 into 3 into 2, 6 minus of 1. 1, we are solving using the first row. And 1 is the element. Now its cofactor 3 into 2, 6 minus 1. Okay. Minus of 2 because it's a first row, second column. So 1 plus 2, odd is the sum. And we have earlier also talked about that this position is negative, and this position is negative, this position is negative, and this position is negative. Like this. Anyways. So minus 2 into excluding the row, excluding the respective column and the row, 2 into 2, 4 minus 3 into 1. Okay, plus 3. Now this element, excluding the column and the row, into 2 into 1, into 3 into 3, that is 9. We have to find out D. 6 minus 1 into 1, 5. Minus 2 into 1, minus 2. 2 minus 9 is minus of 7, multiplied with plus 3, minus of 21. That becomes 5 minus 2, minus 2 minus 21 becomes minus of 23. That becomes minus of 5 minus 23, so minus of 18. When we subtract 23 from 5, that is 18. If 23 is having the negative sign, which is bigger one, so there will be a negative sign with the answer also. So the determinant here is negative. Now D is here less than 0 for sure. Okay, so this option can be correct, and this also can be correct. This cannot be correct, this cannot be correct, because it's excluding the reality that we have just found it out. But we are not aware whether D can become 0 or not. So that's one condition in which we have to be aware about, and we have to check for it for sure, whether D can become 0 or not. So our value putting method is not working here. Yes, it has worked. We have been able to successfully eliminate two options, but we have to eliminate all three to find out one correct option. Okay, so let's expand the method then. Let's expand the determinant given to us. Okay, P into RQ minus P square minus Q into Q square minus PR plus R into Q, PQ minus R square. Okay, so this has become, that is D. PQR minus P cube, Q cube plus PQ, plus PQ plus PQR, that is minus of Q, that's minus minus plus, so that becomes plus PQR. That is also plus PQR, that becomes minus of RQ. So basically this is P3 PQR minus PQ minus QQ minus R. Okay, so this Now we are solving for the possibility whether this determinant can become 0. Is this possible or not? So now let's consider such values of PQR so that it becomes possible. So if we just simply consider PQR as 111, but okay, so considering 111, so that becomes -1, so that becomes 3 into 1, -1, -1, -1. So 3 minus 3, that becomes 0. But the given condition says that they has to be distinct. So D cannot become 0 because they will become 0 only when we are considering some same, equal, identical positive number. So I think that the condition of equality should not be existing here. A should be the correct answer, and it is given so. Okay, so here we can say that we have used two methods in this. In value putting method, you are able to eliminate two options using it. Let's read this. So they have simply expanded it, and they have said that PQ plus QQ plus RQ is always greater than 3PQR when PQR are real positive numbers. And if they are distinct also, these will become 0. These will become equal when and only when PQR are all three numbers are equal. But they are distinct here, so that's why equality condition is not included here. Please take a note of this. This is important. Okay, and particularly this algebraic illustration that we have just seen, it's important. Reread it and ask if any questions. Any doubts?
No, sir.
So in this question, we have to find out the value of determinant. The determinant is given like this, and there is a complex number used here, and iota basically, and the iota values is given. So there are certain value of iotas are given. So for just revising, iota is square root of -1. Iota square is -1. Iota cube is iota square into iota. Iota square is -1 into iota into iota. So that's minus iota. Raised power 4 is its square is -1 square is 1. So similarly, iota raised to power 4r plus n is equals to iota into n, where r is an integer. Basically, if we can break down the number into the sum of multiple of 4 and other. So basically, the r, this particular will be ignored because it's just iota raised to power 4 is 1 only. That's all. So if we simplify the given determinant, so this is iota, this is -1, this is minus of iota. Iota raised to power 4 is 1. Iota raised to power 6 is 4 plus 2. So that is iota square, that is minus 1. Iota raised to power 8 is 4 into 2. So 4 into 2. It's like 4 plus 4. So 1 into 1. So it's, let me write here. Iota raised to power 8 is iota raised to power 4 plus 4. We can write iota raised to power 4 into iota raised to power 4. Iota raised to power 4 is 1. Multiplied with 1, that becomes 1. That's why this is 1. Iota raised to power 9 is 8 plus 1. 8 is a multiple of 4. So can be ignored. 8 plus 1. So that becomes iota raised to power 1. That is the multiple of 4. So its value is 1. 15, 16. So 15 is 12 plus 3. So iota cube. Iota cube's value is minus of iota. Okay, great. So from the given determinant, we can take first row and expand the determinant. Okay. So iota into first row, sorry, first element, its cofactor, minus 1 into minus iota, iota plus iota, minus 1 into minus, minus into 1 into 1. It's 1. Now minus into minus of 1, that becomes plus of 1 into its cofactor, 1 into minus iota, that is minus of iota, 1 into iota, sorry, here minus also, then 1 into iota, iota. Minus of iota, that is the element, its cofactor. So this is the, ignoring this column in the row. So 1 into 1, 1, minus 1 into iota, that is minus of iota, minus minus becomes plus. Okay. So let's solve. And iota square becomes iota square minus of iota, minus of iota, minus, sorry, this is minus of iota becomes minus of 2 iota, plus 1 into minus of 2 iota, we can directly write here. So minus of iota into 1, it's minus of iota, minus of iota into plus of iota, minus iota square. Iota plus iota square minus iota square cancels. Now this becomes minus of 4 iota, minus 1, minus 2, minus 1. This becomes minus of 4 iota. See, that's the correct answer. Any doubts, anyone? Please reread it and ask me if there is any doubt. Try to understand that simply we have simplified the given powers of the iota. Thereafter, we have expanded using the first row. The expansion will be that the multiplication of element in with the respective cofactor. We'll find out the cofactor by ignoring the respective row of the element and the respective column of the element. Then whatever the remaining elements are there, we'll find out its determinant. Clear? Shall we move ahead? Yes,
Yes.
Danish. Yes, if delta is the value of the determinant, okay, then what is the value of the following determinant? Following determinant is somewhat the same. Okay, so if we observe, the first column is got multiplied with P. The third column is got multiplied with the Q. Otherwise, it's the same as the earlier determinant. So we can just take them common, PQ into the whatever remaining is. So we can write it as PQ into delta. So we had to find out its determinant. So if we look in the options, there is a one option matching. So option number D should be the correct answer. So it's a question directly from the property, application of the property. Any doubts, anyone? Please try to observe that we have taken common from the first column and the third column. Then after taking column, let me rewrite it. That after taking column, sorry, after taking common, now taking common P from the first row has become this. Second row similarly, second column similarly. Now taking common Q from the third column has become this. So this whole determinant is the same as of the delta. That's why we have written PQ into 10. Please observe for 5 to 10 seconds and understand how we have solved this question. Questions are not hard. Understanding the property and learning the property, it will make the questions easier for you. Just after reading the question, you'll be able to connect the respective property after observing, because because you know the property. Otherwise, you will not be having any error about the what's happening, what's being asked in the question. Okay, let's move ahead. Okay, clear? Any doubts?
No, sir.
Yes, D is the correct answer. Okay. Okay, so this is one identity. I don't know why I have written it. Algebraic identity. Here's the question. Anyways, move to the next question. If A1, A2, A3, AN, these are 9 terms, are given as in GP, then what is the value of the following determinant? So determinant is given like this: logarithm of A1, logarithm of A2, logarithm of A3. Okay, so we know logarithm, and similarly logarithm of all 9 terms that are there in the GP are given. We know when we take logarithm of any GP, that becomes an AP. So these terms are in AP. Okay, so let's consider the 9 ZP terms, like 2 raised to power 1, 2, 2 raised to power 2, 2 raised to power 3, and 2 raised to power 9. If I take logarithm to the base 2, okay, or should I consider differently that the GP is having E as its common ratio? Okay, so now if I take its logarithm, logarithm of e to the base e, this has become 1. Logarithm of e square to the base e, this has become 2. Similarly, 1, 2, 3, 4, 5, 6, 9. So this has become 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it's easy to take its determinant, isn't it? Okay, so let's write the determinant here. 1, 2, 3, 3, 4, 5, 6, 7, 8. Nice. I've done a mistake. 1, 2, 3, that is 4, 5, 6, 7, 8, 9. Expanding using the first row. 1, expanding using the first row. Now its cofactor 5 into 9, 45, minus 8 into 6, 48, minus of 2 into 4 into 9, 36, minus 6 into 7, 42, plus 3, 4 into 8, 32, minus 7 into 5, 35. Okay. 45 minus 48, minus of 3, minus of 2 into 36 minus 42 becomes 4 to 6, minus of 6. Minus 2 into minus 6 plus 12. 32 minus 35 becomes minus of 3, plus 3 into minus 3, that has become minus of 9. 12 minus 3 minus 9, that is 12 minus 12, that is 0. A should be the correct answer. Any doubts, anyone?
No, sir.
Yeah. Please understand that these given terms were given in GP. So if you take logarithm of any GP, that becomes an AP. Okay. So using that understanding, we have assumed that the GP is as simple as that we have assumed here, e raised to power 1, a raised to power 2. The common ratio is e here. And uh, And similarly, after taking its logarithm, that has become logarithm of e become 1, e logarithm of e square becomes 2. Similarly, logarithm of e raised to power 9 of to the base e, that has become 9, because 9 into this is the power will get multiplied with the logarithm of e to the base e is 1, that's why it's 9. Clear, everyone?
Yes, sir.
Okay, so the givens, if you would not have considered any GP, then this much long solution, you have to apply multiple operations and then solve this. The question is, if A and B are the square matrices of order 2, such that the determinant of AB is equals to determinant of BA, then which one of the following is correct? So determinant of AB is given as equals to determinant of BA matrix. Now, okay, then which one of the following is correct? Now we have to read the options and statements. We have to justify them whether they are and verify them whether they are correct or not. A must be a unit matrix. So if A were be a unit matrix, yes, this condition would satisfy. Unit matrix into B into unit matrix. So this becomes B only. This becomes B also. So using the A option, that can get satisfied for sure, can work. But it's not the only condition that A has to be one. A has to be a unit matrix, or B has to be a unit matrix. No. Otherwise, also we know that AB matrix is equals to BA matrix when A and B are symmetric matrices. So if we go back and open our notes, there's a property in symmetric matrices that AB is equals to BA when B is symmetric matrix or A is symmetric matrix. No, I have just checked the condition that I was talking about. That condition was if A and B are, this is wrong, symmetric matrices, then, and one more condition, if AB is equals to BA, then we may say that AB is also symmetric matrix. So that's about that's a property talking about the symmetricity of AB. Okay, so what I was talking about was different, but my point is that AB is equals to BA. Not always it is true, but sometimes it can be true. AB can be equals to BA. So when it can be true, let me tell you when it can be true. Let's say A matrix is, let's say A determinant is 2, 4, 0, 0. Its determinant is 8. B matrix is 8, 0, 1, 0. Now its determinant is 8 also. Now see one thing. Okay, let's now find out AB. 2 into 0 into 8 into 0. So 2 into 8, 16 plus 0, 16. 2 into 0, 0. 0 into 1, 0. Okay. 0 into 4, 0 into 8 plus 4 into 0, 0. 0 into 0 plus 4 into 1, 4. AB is this. Let's now find out BA. BA is 8 into 2, that is 16 plus 0, 16. 8 into 0 plus 0 into 4, 0. Now 0 into 2 plus 1 into 0, that is 0. Now 0 into 0 into 1 plus 4, that is 4. Now here we can see AB is equals to BA. Whereas A and B, both of them are diagonal matrix, but they are not unit matrices. So A and B need not to be unit matrices always. Okay. So must is a kind of helping verb which is saying that it's a compulsion, and only A being or B being the unit matrix, then only this property can satisfy. But that's not the case. We have just proved here here the determinant of AB and BA are for sure equal. 16 into 4, that is 64, and 16 into 4, that is 64 if we write. Okay, please read the question once again, and if there is any doubt, ask me again. These questions where there are statements, you have to be very careful with them and read them very exactly so that you understand what the statement is saying, and you have to be articulate with the statement. If the statement is my voice audible?
Yes, sir.
Yeah. So if the statement is having any particular, if there were can, A can be a unit matrix. Can use instead of must, then A can become the answer. Okay. So this is how nuances matters. Okay, let's move ahead for the next question. This is the correct answer. Yes. If the determinant, okay, this is the determinant having x as one variable and thus a number given as 0, then we have to find out the only variable that is there in the equation. Okay. So solve using the second row because there is maximum number of zeros in that. So 0 into anything doesn't matter. 0 into its cofactor doesn't matter. Plus 1. Now this is the second row, third column. So 2 plus 3, 5. There will be a negative sign here. And into ignoring its row and the column, x into x square minus of 1 is equals to 0. Okay, simplifying x square minus 1 should be 0. X square is equals to minus 1. X is minus of 1. Sorry, x is plus of 1. Plus of 1 square root, that is plus minus 1. Option number C should be the correct answer. Any doubts, anyone?
No, sir.
Yeah, please reread and try to understand the question. Is the question clear?
Yes, sir.
Is the solution clear? Okay, so in the next question, there is a function given in the form of a determinant. There is a variable x. The function is having only single variable. Okay, and we have to find out the value of f of minus 1, f of 0, and then we have to sum the whole value of function with minus 1, 0, and 1. 1. Great. So first, let's simplify the function. So in this, we can see x minus 1 is common in the third row. Okay. And in the second row, x is common. And in the third row also, x was also common. No, x was not common. In the first, okay, great. So let's take x common from the second row, x minus 1 common from the third row. First row is untouched. Second row is 2 into x minus 1 to x plus 1. Third row is 3 of x into 2 into x minus 2. So 2x minus 4. X into x plus 1, that is square plus x. Now we can see Now instead of writing x square plus x, let's simply write it x into x plus 1. Because we are saying x plus 1 is common in third column. And is there something common in the second column? No. There's something common here? No. So let's take x into x minus 1 into x plus 1 common also. So 1, 2, 3 x, x minus 1, 2x minus 4, 1, 1 into x. Great. So now this is the function. If we try to find out f of minus 1, for f of minus 1, this value will become 0. Minus 1 plus 1 will become 0. Hence, we can write f of minus 1 is 0. Are you able to understand this fact that why this will become 0? Because if one term is becoming 0 and some other terms are getting multiplied with it, then the whole product will also be 0. That's my point. Are you able to understand it? Is that clear?
Yes, sir.
Okay. Now, similarly, finding f of 0, this has become 0. 0 into anything will make f of 0 is 0 only. So our work is easy now. Okay. So now our work is easy now. Now let's find out f of 1 because we have to sum them up. F of 1 is 0 because 1 minus 1 is also 0. So 0 into anything will make it 0 only. So 0 plus 0 plus 0 will make it 0 only. So that's why A option is our correct answer. पता नहीं क्या दे रखा है. A option is the correct answer. Answer is correct. Please understand it that we have just observed the given determinant, taken something common, and then smartly have solved it. Otherwise, it will take more like lot of time for you to solve, and also there are higher chances of calculation mistakes if you are going to solve that big calculations. Observe the determinant that is given. We have taken common. First x from the second row, x minus 1 from the third row, thereafter x plus 1 from the third column. Now we have observed, if we go on by putting and substituting values of x with minus 1, 0 and plus 1, that the value of the function are becoming 0, 0, 0. So after adding 0, 0, 0, 0, the overall sum is 0 only. Is that clear, everyone? Yes?
Yes, sir.
Okay. The element in the ith row and the jth column of a determinant of third order. Let's say there is a determinant. Okay. If the element in the ith row, so 3 by 3 column. Let's say let's assume the ith row is 1, I is 1 and j is 2. Okay, so the element in the first row and second column, this element is equal to 2 into I was 1 into 2. Okay, is equal to 2 into 1 plus, so 2 into 3, that is 6. Okay, this is given as 6. So what? The element in the ith row. Okay, so this is basically Aij that is given to us 2 into I plus j. Okay, so simple. I have got to know that what we can do here. Instead of assuming, we don't assume. It's the general thing that is given to us, that the element is following this function. So A11 will be 2 into I plus j, that is 1 plus 1, that will become 2 into 2, 4. So this is 4. And similarly, we'll find out all the elements 4, 6, 8. Why? This is first, 1 plus 1 into 2. This is first row, second column into 2. Similarly, we have find it out and thereafter we'll solve it. Its value will come out as 0. We are running out of time. That's why I haven't solved it. I've tell you the concept. Clear?
Yes, sir.
Any doubts? No doubts. Okay, so thank you.